So we're talking point slope form on this guy here, in this video here. And the point slope form looks like this. And I personally prefer this form over the other forms. Not that matters because you're going to have to submit answers to the software. But I find this extremely useful, and it opposes the whole slope-intercept predominance in math education, but at least at the high school level. This clearly is very much like all of our polynomials and other functions where we want to talk about translations. And so the x1 and y1 represents a translation from the origin, so from the parent function y equals x. But that's not really part of this discussion. If you want to talk about that more, I can talk about it in great detail. So if we go back to the idea that a line is defined specifically in order to have a unique line by 2 points, that's your basic geometry. And so I've plucked out these points, 2, 4, and this one over here, -5, -2, as 2 points. With those 2 points, I can find the slope of a line, and we've done this a number of times thus far. So the slope is defined as the change in y divided by the change in x, or the change in the vertical distance from one point to another divided by the horizontal distance from one point to another. So graphically, that would look, I don't think I shared this in the other videos, but graphically, it would look like, I don't want to do that. It would look like this. This is your change in y, and this would be your change in x. Change in x. I'm using the symbol delta because delta was the Greek letter change. So if we continue with this, I'm going to identify this as my y2. And so this is going to be 4 minus my -2 and 2 minus my -5. I'm going to end up getting a slope of 4 plus 2 is 6 and 2 plus 5 is 7. So I get a slope of 6/7. And then I can choose any of these points, of which I only have 2 pulled out. I have 2 points that I can choose from, and I can choose either of the 2. And so I can write my equation for this green line as y minus the y value 4 equals the slope 6/7 times x minus the x value 2 for this particular point. And so if that's all I'm asked and I'm able to, I'm putting that as my answer. Typically the software is going to ask you to change that to slope-intercept form. So let's go through that process now. I'm going to leave the y minus 4 alone at this point in time, and I'm going to distribute the 6/7 to both of these terms inside the parentheses. So I'm going to get 6/7 times x minus 2 times 6/7, which is 12/7. And then I'm going to come to the left side again and add 4. Why am I adding 4? Because I want this to be 0 and leave me with just the y. And so I'm going to add 4 to the right-hand side as well. That leaves me with 6/7 x minus 12/7, and I have to get common denominator, so I'm going to add 28/7 because this is the number 4 written as a fraction over 7. And so my final representation of this line, this green line right over here, in slope-intercept form is y equals 6/7 x plus, and I'll take 28 and subtract 12, and I'll get 16/7. Doesn't look like I can simplify anything, so that's my equation in slope-intercept form. This is the equation in point-slope form, and they're equivalent. Though they look different, they are equivalent functions, and they describe all the points on that green line in my coordinate system. So that's point slope.